All right, so I've kind of found that some topics have been coming up a lot in EE 330 or 3300, where I help a lot of students with similar issues. So I'm going to start trying to record some videos on common problems and solutions and uploading those to Canvas so that I can just point you to that video instead of having to take time to explain stuff every single time an issue comes up. And additionally, I might try to also record some different like tips and tricks as I think of them so that you guys can have this and not require me to teach it to you in case you forget. That way we have it recorded. So in my Tuesday lab section, I talked about this, and I'm not sure if I got to it in the Friday lab section or not. But I want to talk, or I want to make this video just about how to use variables in your schematics and simulations in Cadence. So over here, I have this schematic, and you should recognize this. This is the uh, basically the ESD protection circuit that we had you make in lab. And then mine, instead of having pins and whatnot, I just have it all connected up in here. This is just for my own testing quick before the lab. So when we had you simulate this, we had you vary the initial condition, say like 2000 volts, 200 volts, whatever. We had you vary this and look at the output voltage to see if it got above 5 volts or not. So one way to do this that makes it easier is instead of having to go in here and change the setting, then run your simulation, check your results, then come back, change it again, go back, check your results. That takes a lot of time. Instead, you can use a variable. So instead of just giving this a number, I can give it a name. So I'll call it like any cond. So initial condition, just shortened. And I'm just gonna hit tab so you can see what happens here. It just adds a little volts on, but everything else is the same. And I'm gonna hit OK, and then I can check and save. And then I can open my Maestro using ADE Explorer. And this is one that I previously created. Let me delete this. This is for my previous stuff. Okay, so now over here, when you have your Maestro open, you should see this like design variables section. And if you click here, click to add variable, it'll bring up this window. And over here at the bottom, it says cell view variables. So if you have any variables in your schematic, you can copy them into your simulation using this copy from. So I just click this copy from. You can see it copies in my any cond variable that I made in the schematic. So now I can just click OK. And I can give this a value. So if I just wanted to give this a single value, say like 250 volts, then I can just double click, and in this box I can add 250. And boom, now when I run my simulation, it will give this capacitor an initial condition of 250 volts. Some additional things I can do is if I want to test multiple values, let's say like 250 and 500, I can just add a space between each value and then type in all my values. So let's say I did 250, 500, 1000. You can also use the same suffixes as you use for other things. So 2K is 2000, and then enter. And so this is my 4 values I want to test, and they're each separated by a space. And if I were to run this, actually, I'll just run. Yeah, I'll run this. If I were to run this, then what we're going to see is that it runs 4 simulations. So first it sets my variable to 250, then it runs a simulation, then 500 runs a simulation, 1000 runs a simulation, 2000 runs a simulation. And I get results for each one. So I'm going to wait for this to wrap up here. And it's deciding to take a little bit. Okay, and then it plots all my results. I'm just going to close this for now. So if you just want to look at the results from, say, only 250, let's say I want to look at my in. I think my in is this guy, the input to my ESD protection and, or actually, wait. Yeah, in is my input to the ESD protection, out is to the output. So you can also name, I'm grabbing the waveforms and I'm giving them different names here. Yeah, that's kind of beside the point. But so if I want to look at my in and my out, then I can just select the top one and hold Control, and then click the next one, and then I can right click on it and then hit plot. And that'll only plot in and out for 250 volts. And then I can see here I'm well below. If I go back, let's say I wanted to plot out for 250 and 500. Again, I can hold, I can click this, hold Control, click this guy, right click, plot. And that'll plot the two. And over on the left here, you can see you have this out and it says two child traces. So if I click the little plus, it shows the conditions for these traces. So 250, 500. You can see the differences between them here. And then if I want to plot, say I want to plot out for all of them, one thing I can do is I can just right click on one of them and then hit plot all. And that will plot it for 250, 500, 1000, 2000. And I can take a look at all of those there. So that's pretty much what you need for this past lab. But I want to talk about a few more things about variables that might be useful in the future. So in addition, if you want to do a linear sweep, so you sweep the variable from a lower bound to an upper bound with equally spaced points. A quick way to add this is you can just double click to get into this, delete it. Now let's say I want to do like 100 volts to 1000 volts with steps of 100 volts. So I'll simulate 100 volts, then 200 volts, then 300 volts, so on until I get to 1000. I can put in my lower bound value and then a colon, and then my step size, which I can set as 100, colon, and then my upper bound. So if I do this and I run, then it'll run for initial condition equal to 100, then 200, 300, 400, 500, 600, all the way up to 1000. And I'm going to stop the simulation because it's going to take a little bit to run. I can also set up different types of sweeps by clicking on this button with 3 dots on the right. So if you click this, it opens up this parameterized window. And right now you can see it has from to selected. And this is because this is basically the syntax for a from to. So I'm just going to delete this. So if you don't have anything in here, it'll open like this. And you can select a type of specification to add. I'll pick like so an inclusion list. If I do this, then I can add my values. So this is what we did the first time, like 100, 200, 300, and it includes those 3 values. And I'll delete that. You can also add like a from to. So this is, you can select your type of, or let's say I want to go from 100, I'll go to 1000, and then I can either set the total number of steps, or I can set linear, then I can set my step size. That's what I did earlier. I can select logarithmic, which means it'll run a logarithmic sweep where like you'll have 10 points per decade or 100 points per decade or whatever. Yeah, there's a number of different types you can do. You can do center span. There's a lot of different stuff. I'm going to let you play around with this for whatever you need, but just know that's there. So let's put this back to 250. Okay, this video is getting a little long now, but another thing you can do is you can just add variables that aren't in your schematic. And so let's say I wanted to like be able to quickly change how long my transient simulation runs for, or let's say I wanted to run it for different amounts of time for different simulations, then I'll create a variable called stop time, and I'll just give it a value of 1 micro for now, 1 microsecond. And you can see this variable stop time here. And if I open up or I can use this variable other places in my simulation setup. So if I want to use it for my transient setup, instead of typing in stop time 1U here, I can use this function all uppercase VAR, and then in parentheses and quotes, I can put my variable name, stop time. And so now, sorry, I just kind of clicked enter after that. Okay, it's not going to format nice, but now you can see it set stop time. Okay. And if I were to run my simulation, and wait for it to run, then now it'll run for 1 microsecond. Whereas I could then set it for like 100 nanoseconds. And if I ran again, then now you can see it only runs for 100 nanoseconds. So that's one way you can do it. You can also use it for building calculations in here. You can use that same var, but I won't go into that too much more. Let's see, the one last thing I'll say, just a lot of this, like for this lab, you just need like the first 5 minutes of this video, but I want to just show some more advanced concepts. So let's say I wanted to vary the resistance of this guy for some reason. Okay, this can be different parameters, so you might want to have multiple variables in your schematic. So for this example, I'll just use this resistance. Let's say I wanted to vary this guy. So I'll give it a name, res. And then if I check and save my schematic, and then go back to here, I'll click to add variable, copy from, that copies in this res, hit OK. And I can set this to like 1.5K, and I'll try like 5K. And so if I set res to this, and then I set my initial condition, let's say 250 and 500 volts. Now if I run the simulation, it's going to nest these, which means it's going to run every single different combination of variables. So you can see I have two different values for initial condition, two different values for the resistance, and that creates 4 different sweeps. So one where it's 250 and 1.5K, one where it's 250 and 5K, one where it's 500 and 1.5, one where it's 500 and 5K. So it will create a big nested sweep. That can be quite useful. However, sometimes you also want to fix certain things together. So let's say I wanted to run like, I also wanted to run, or yeah, let's say I wanted to test 250 with 1.5K only and 500 with 5K only. But I didn't want to create 4. I just wanted 2 different simulation runs. Then what I can do is I can hold control and or click on one variable, hold control, click on another variable, right click, and then go group as parametric set. If I do this, it highlights these to show that they're together. And now it's the first value of this guy corresponds to the first value of this guy. Second value corresponds to the second value, so on and so forth. I'm pretty sure they need to have the same number of values for this to work. And if I simulate, then now it only runs 2 simulations. One with 1.5K and 250, and one with 5K and 500. So this can be useful at times. You might not always need this, but could be helpful. So I just wanted to put all this out there. Might be helpful for you guys as you go along in labs and final project. And I hope you have a good day. So.